Yes, and that is what we have seen in the last class. In the today's concerning the today's class, we'll see the robot configuration, the mechanical configuration, that is robot classification, robot arm geometry, and the thrust areas, and if feasible, we'll visit the control techniques. And we'll start with the mechanical configurations. Yes, it is. Nishant, it is visible. Concerning today's class, I request some people to join with us. And
yes, sir, it's visible.
yes, I think the name list also visible. Is it right?
Yes, sir.
Yes. In the last class, I think till 40 joined. I think so joined in the last class. From the in the today's class, I request 43. That is 43, 44, 45, 46 till 53. You please unmute your mic and please join with us till KD Singh. KD Singh, please unmute your mic and please join with us.
Yes, sir.
Joram Josana and Campbell Komal and Ganesh Kumar, Ajay, Ritik Kumar. Pradhan, please unmute your mic and please join with us. Please one.
Unmuted, sir.
Yes, very good,
Yes,
very
sir.
good. Yes, please
Yes, sir.
unmute and, your mic and please join with us. And concerning if when we are handling the classes after 12:30 or when there is an afternoon session, usually we'll discuss the contents related to not to wake up you. We'll discuss the puzzle or mathematical contents which wake up you. Like that, we have today's. I request Sabrani and Nishan to share each one. They will share the puzzle, and if feasible, you try to resolve it and tell me. And Sabrani, please go ahead, Sabrani.
Yes, sir. So the first puzzle is that a person's office is on the 100th floor, and all around the year, in sunny days, he avails the entire staircase, but whenever it rains, no, like during rainy days, he'll only avail the lift, but for the other days, he uses the lift for some part of the journey, and the others, he walks up through the stairs.
Think over the puzzle and please tell me the answer. Don't take much time because already it is 12:39.
Sir, is that for everyone?
And not for numerical method students. Already you know the answers. Those who didn't attended numerical methods, they can. KD Singh, KD Singh, KD Singh, please unmute your
Yes,
mic, KD Singh.
yes, sir.
The question is understandable. Are you able
Yes,
to get the question?
yes, sir. Yes, I get the question.
Yes, what might be the answer?
Thinking, sir, it may
Thinking.
be
Okay, you
geometry.
think. And Nishant?
Yes, sir.
Yes, you share your puzzle, Nishant.
So a bear is falling from a height of on the ground and square root of 2 seconds. What is the color of the bear?
Again, repeat the question, Nishant.
So a bear is falling from a hill of height 10 meters to the ground on in uh, square root of 2 seconds. What is the color of the bear?
A pair of which is falling from the which is falling? A pair of
A bear is falling.
Bear is falling. Okay.
Answer black.
Yes. Someone unmuted. Yes, go ahead with your answer.
Sir, I think the answer is black color, sir.
Your answer is black.
Yes,
How?
sir.
How? You are from numerical
Sir,
methods.
because
You are from numerical methods. No, then
No,
no,
sir,
go
no,
ahead. Go ahead.
sir, because I have not seen bear any other color than black, sir.
What is your name?
Yes, Amrut, sir.
Samruddh. Have you seen? Have you never about the beers in the polar? What was the color of the beer?
Sir, that the color is white, sir.
Then have you seen the ad which was disseminated by Gems? There is in
That,
chocolate.
that's a combination of black and white, sir. So basically, two colors only,
Okay.
sir.
Then
White.
what
So
might be the answer? Okay, think over these questions. Once we come across some
Sir,
contents today. Yes, go ahead.
sir, I think I have the answer for what the previous question is about the lift question. I
Yes,
think
what is your name? What is the name?
Tanige Satyan, sir.
Tanigesh Satyan.
Yes, sir.
Tanigesh, நீங்க தமிழ்நாடுப்பா தமிழ்நாடு
ஆமா தமிழ் தணிகை சார்.
தணிகை
சத்யன் கூப்பிடுங்க சார்.
சத்யன் தணிகை சத்யன் பேர் நல்லா இருக்க பேரு ஏன்பா பாதி பேர் ஏன்பா கூப்பிட சொல்றேன் நல்லா இருக்குப்பா ஃபுல் பேர் நல்லா இருக்குப்பா go ahead with your answer தணிகை சத்யன்
Sir, I think the person might be a little short, so in the rainy season he might use some umbrella or something, and then he might use it to, he can't able to reach the floor that he is required to go, so he can use the number which is below, and then he can go up with the umbrella he can use to click the number of floors he want to go during the rainy season.
yes Sabarni
Yes, correct.
yes of course Tanigai of course very good
Thanks.
yes in order to get back to the question from Nishant will spend some little time with the slides and then we'll move towards Nishant question. Okay, concerning the today's class, that is we are not entered with any programming or any languages. Anyway, today I'll disseminate. We'll start from known to unknown. We'll make a move. We'll start a little programming and we'll introduce some codings and all. And anyway, we before that we should be very aware with the nomenclatures and the terminologies related to robotics. That is what the objective and once we are very familiar with these nomenclatures and these basic information, then we'll start and then we'll give a very good insight towards the third unit, robotic programming and all. And anyway, the today's content is the common robot configuration. There are two different types of configurations or generally classified: a robot arm assembly with 3 degrees of freedom and a wrist assembly with 2 or 3 degrees of freedom. And see some of the common robot configuration or the mechanical configurations are Cartesian coordinate configuration, cylindrical configuration, spherical on jointed arm configuration. Here there are 5 different configurations are given. One is polar, cylindrical, Cartesian, jointed arm, and SCARA. And SCARA is an sub classification of jointed arm robot. Therefore, we have 4 different classifications: polar, cylindrical, Cartesian, and jointed arm. We can add one more with that this configuration, that is spherical configuration. Therefore, we have 5 different configuration: polar, cylindrical, Cartesian, jointed arm, and spherical configuration. Okay, we'll see one by one what all the configuration, what it can do, what are the flexibility, and what was the work envelope or work volume of each robot configuration. And this is a typical example for the mechanical configurations. And the first one, concerning the first one, it can move linearly, and sliding arm, that is L joint, we have L joint actuated relative to the body, which rotates around both the vertical and the horizontal axis. And this type of the robotic arm can be classified as polar configuration, and it has cylinderical configuration. There is a vertical column with a robot arm which can slide, move up and down. That is simultaneously the arm can move radially with respect to the column. And the main drawback with this cylindrical configuration is it cannot, that is full 360 rotation is not possible. That is a main drawback to the restriction by the hydraulic or electrical or pneumatic connections. Once we have one video with this mechanical configuration. Once the video is played, you can able to see what was the drawback with the cylindrical configuration, and you may be aware about various other configuration and all. And there is an we have one vertical column, and there is a possibility of rotary motion, and this arm move linearly, and therefore it has 2 degrees of freedom. And concerning this is a different example, and in order to know the work envelope of this particular system, we have given this illustration, and see the cylindrical configuration, cylindrical work volume or work envelope of this particular type of robot. And this is also some other example, and see there is a rotary motion is possible, and it can move up and down, and it can to and fro motion is also feasible. And Cartesian, concerning the Cartesian robot, and it can be available with the 2 different types. One is cantilever Cartesian, the other one in gantry style Cartesian. And this is an example for cantilever Cartesian, and this is an example for gantry style Cartesian. And it can move in 3 different dimensions, that is x and y is that. And the work envelope, we have seen, we have shown a video. In that video it was clearly demonstrated that the work volume of this particular type of robot can cover a rectangular, a square, or a rectangular or a square type of volume it covers. The 3 mutual perpendicular axes which define a rectangular work volume. And concerning the see here, there is a possibility of movement in the up and down, and here there is a linear motion. Here also we have the linear motion, and the therefore there's 3 mutually perpendicular axes. We can work with 3 different axes, and this is an typical example of a Cartesian coordinate configuration. Gantry style Cartesian robot. And when extremely heavy loads, we need to use these type of gantry style robots. They often mounted on the ceiling. See, there is a ceiling on, there is a column, vertical column. It moves over the vertical column, and generally more rigid, but may provide less access to the workspace. And this is a typical example of the Cartesian coordinate configuration. And the third one is the spherical robot, and it sometimes it may be called as a polar robot, and it is very similar to that of the cylindrical robot, but from a spherical range of motion using a polar coordinate system, it can covers the cylindrical envelope. And concerning this articulated arm robot has at least 3 rotary joints. They are frequently called as this can resembles the human arm. Therefore, it is usually called as anthropomorphic arm. And this is in subclassification of articulated arm robot. And concerning the SCARA robot, and it has various joints, like 4 different joints. Selective compliance assembly robot arm. It is usually called as SCARA robot, and relatively inexpensive and are used in application that requires rapid and smooth motions. And here it is extremely stiff in the vertical directions, but it has some lateral compliance. Therefore, it is name itself indicates the selective compliance assembly robot. Once again, I am repeating, it is extremely stiff in the vertical direction, but as it has the lateral compliance, therefore it is called as selective compliance assembly robot arm. And see some different pictures, illustrations of SCARA robot. Here it can move up and down. There is an movement possible in the joint 2, 3 as well 4, and see the rotary motions in other joints. And see here some other robot classification. The parallel robots are shown here, and in Munchman Park and all, in order to give a realistic flight simulation, they usually prefer the parallel robots. And concerning the other applications and the application areas, in order to do palletizing and depalletizing, the robots are usually used. To see the typical example or a photo illustration of robots which does the palletizing and depalletizing. And see, in order to do the micro drilling, that is precise machining where we required, we can apply robotic arm to do so. And we need, but the thing is, we need to appropriately choose the end effector in order to perform the specific task. And spot welding can be the most common application. We are using the robotic arm. And for fastening and all, the robot are usually adopted in mechanical industry. Concerning the electronic industry, the screwing components to the circuit boards and the chassis board into the chassis can be done with the help of with the aid of robotic arm. And in order to perform the painting and all, painting and compound spraying, it can be performed very well. And see here, painting both are hazardous because the paint material is often toxic and flammable. At that time, the human presence should not be there. At that time, we can prefer robotic arm to do so. And concerning the robot configuration, and we will see one video in order to understand what is roll, what is pitch and yaw, and then we will come back to this slide. The universe. Yes, check with the audio.
Yes, sir.
Yes.
Universal Robot, also named 3R Robot due to its access, is the most used industrial robot because of its high flexibility. A reason for us to have a closer look at its schematic. Our fellow will drive each axis.
Please make a note of this degrees of freedom and with the same order. We have waist, shoulder and elbow. Please make a note of these contents. Waist, shoulder and elbow. Subsequently we have roll, pitch and yaw. Please make a note.
With his teach panel, so we get an impression of this robot. First axis drives the waist. The second axis moves the robot's shoulder. The elbow of the robot is driven by the third axis. With these three axes, you can position the TCP within the work envelope of the robot.
We can position the TCP, that is TCP in the sense tool center point.
If the robot slides along a track, he would have a further degree of freedom in form of a linear movement.
This I have already disseminated. When we have the rail over
the work
bottom,
envelope can be described.
Then it has some other degrees of freedom also. When we are talking about the movement, we need to worry about the work volume. That we need to have a conscious over the work volume.
As spherical.
The work volume.
The angle. The work envelope can be described as spherical.
It has spherical work.
The angle of the robot hand is named as orientation. In this context, you use terms which comes from aviation. Roll rotates the tool about its center.
Yes. It has roll, pitch and yaw. Please make a note. Roll, pitch and yaw.
Axis. Moves with tool vertically. Yaw turns the tool left and right, so you get a maximum of 6 degrees of freedom. You would use this robot for...
This 3 degrees of freedom are related to the wrist configuration. Wrist has this 3 degrees of freedom, which is roll, pitch and yaw. Please remember.
Roll rotates the tool about its center axis. Moves with tool vertically.
Pitch.
Yaw turns the tool left and right, so you get a maximum of 6 degrees of freedom. You would use this robot for application like complex mounting, arc welding, and painting. Let's have a look at how this SCARA can pick these electronic devices and in their boxes with high velocity. What makes this industrial robot so unique? On the top view, you can see how this robot gets its high speed at TCP.
See, there are 2 different inclinations were mentioned here. One is beta 1 and the other one is beta 2.
The angular velocities of both joints are added. The other big advantage is this robot can hold heavy workpieces and can build high forces in the vertical direction due to its axes, which are mechanically rigid in the vertical. This robot provides a circular workspace and can reach almost 360 degrees.
Almost 360 degrees they are saying. And see?
Can reach almost 360 degrees around itself. With a small footprint, the SCARA gets...
It won't be possible. The 360 degrees won't be possible due to the mechanical constraints, or whether it may be mechanical or hydraulic constraints. It can cover a maximum of 360.
It's a wide range. You get a SCARA normally with 4 degrees of freedom. Here's a short overview of the advantages, disadvantages, and typical applications of a SCARA as a summary.
Pick and place, simple mounting and packaging. See the limited movements. High speed in the horizontal, fast repeatable point-to-point movement, high force within the vertical direction.
Cartesian or linear robots consists of a manipulator mounted onto an overhead system that allows movement across a horizontal plane. Here, you see a gantry robot handling heavy weights. Due to its axis, this robot is perfect for pick and place.
What is mean by that L? What it denotes? What is mean by L? Someone? What is mean by L? L. What is mean by L? KD Singh, your team? That is 41 to 50. I have requested some people to unmute. You go ahead with what is L? Someone from others? What is
Sir,
mean
is
by
it
L?
linear?
Linear joint. Linear joint. Yes, of course.
Applications, and this for a large work area. Gantry robots are easier to program with respect to motion because they work with an XYZ coordinate system. The workspace has the shape of a rectangle.
We can call it as a workspace or work envelope. The maximum volume covered by the system is said to be a workspace or work envelope.
You can find this robot not only for handling heavy weights. Here, you see an SMD assembly system with a 3L kinematic. Robots with 3 linear axes provide the advantage of high positioning accuracy because the position of the axis can be measured directly. More videos about robots you get in our playlist. Watch also our next videos.
There are 4 main types of robotic
This
arm
we have already
geometry:
disseminated.
rectangular, cylindrical.
See the gripper and gripper information. The linear motion, we can convert the linear motion now to hold some particular job or geometry. How the mechanical system can be used to hold or grip a job. In this particular case, how many joints we have now to actuate a single gripper? See, 1, 2, 3, 4, and 5, and concerning this one 6. Not to actuate a single hand, we have 6 different joints. Similarly, here 1, 2, 3, 4, 5, 5 different joints, and totally we have 5 plus 6, 11 joints in order to grip a simple task. In order to perform a simple task, we need to put 11 different joints, and similarly we have n number of links. See the gripper, how it performs with some other in the past we doesn't have the motors. In the past video we have used the hydraulic system not to actuate the gripper, but concerning this particular case, we were using the motors and gears to use see not to actuate, not to make movement. Here we are using motors. In the last video we doesn't have any motors. We are using the hydraulic system. The last case, concerning this particular case, and we are using the electrical power, electrical motors, and with that we are having the gears, and please about that, what was the gear used here? Tell me, what is the gear? This is, what was the name of this system?
Rack and pinion.
Rack and pinion. No. Someone idea?
Spur gears.
Worm and worm wheel. Okay, I'll tell you the various other classification. Spur, helical, bevel, worm, cross helical. There were some gears: spur, bevel, helical, cross helical, and as you said, the rack and pinion, ratchet ball. These are some system. You please go ahead and try to do the search. And in this particular video, we have seen the gripper with the aid of this gear and gear arrangement with the motors. And okay, well, again we'll go to a slide, and therefore in the wrist configuration we need to remember the 3 degrees of freedom, that is roll, pitch, and yaw. Roll, pitch, and yaw. See, this is the roll and yaw and pitch. Roll, yaw, and pitch. That we need to remember this 3 degrees of freedom with wrist configuration. These are the drives which is usually used in order to actuate the various grippers and all. Electrical, we have electrical, hydraulic, and pneumatic. Electrical, hydraulic, and pneumatic. And this robotical control system will disseminate little more about the robotical control system in the next class. And go ahead and please make a note with this basic informations of the commands. Please make a note. Please make a note of this contents. The input interlock we are going to use Y20 on. The output interlock signal 10 on, signal 10 6.0, and interlock for continuous monitoring. REACT25 STOP. React 25 safe stop. And concerning the gripper command, please make a note to open and close. For servo control hands, we have close 25 mm and close to 0.0 n. Please make a note of these contents. Slowly we will enter into the programming and the language part. I think you have noted down and see the example of one particular motion programming command, and I'll let you know this information a little later. Okay, and see the mechanical gripper, and that's all about today's presentation. And over to Nishant. And Nishant will expect the answers from someone. Others? Yes, tell me. Yes, respond for Nishant question. Yes, we have some other time also. Yes, we have some other time also. Yes, we'll discuss a little more about grippers. Yes, once the Nishant content is over, we'll talk about the grippers. Yes. Yes, tell me. Tell me.
Sir, is it a polar bear? I mean, the color is white. Like,
okay. How?
Shant's question.
How?
Because he told the acceleration due to gravity is 10 meter per second square. So in the pole, I mean, at the poles only it's maximum. So I think the bear should be from the polar region. So it should be a polar bear, and the time taken is root 2 seconds. That's what he told. So I think it's a polar bear, sir.
How you got the gravity from these data?
No, that's what he told. 10. It's the that's what he told, sir. 10 meter per second square. I think
that
so.
is hidden information or it is direct information?
I think
you told the height was 10 meters, no, sir.
Yeah, she got
the... okay. So the height half GT square, I guess. So so the gravity should be 10.
Yes, very good. Do you go ahead, Nishant?
Yes, sir. That is the answer. Because height is 10, we took half GT square and we got G as 10. And
okay.
G maximum in towards near the poles, so it's a polar bear. Polar bears are white.
Yes, absolutely. Very good. Sri Ranjini.
Yes, sir. Yes,
you are from?
B section. I'm sorry, A section, sir.
Yeah.
A section.
Belongs to? What was your native?
Oh, Chennai, sir.
Chennai. Arun Balaji and Sri Ranjini responded. Very good. Okay, concerning the when we are talking about the various configurations and applications of robots, then we need to worry about the mishappening that is in Himalayan. What happened in last few days? There are 171 people stuck in the. See, there is a huge accident with the mines, and is it so? Anyone go ahead with that? Trapped
yes.
Some. Yes, go ahead.
Uttarakhand, it was tragedy in Uttarakhand, sir.
Yes, Gaurav Singh, yes.
Yes, it was recent tragedy in Uttarakhand, sir. Many people were reported missing and many people lost their lives, sir.
What happened?
I was talking about an incident in the Himalayan region which you are talking, sir. Recently, it happened in a week, sir.
Yes. Tapovan at Tapovan tunnel, Chamoli district of Uttarakhand, of course.
Yes, sir.
Yes. Is it any we have any risk robots in order to risk the people from who stuck with that tunnel? We have any robotic facilities in practice, whether we have any industrial robot to recover
So
some
drones
people.
were used for laser recognition.
Yes, Tatacharya, yes. Narayana
The drones were used to laser imaging inside the tunnel.
Laser imaging.
So, I guess so.
Okay, that might be, but for in order to do risk, do you have any system?
So there the head of the tunnel was blocked. So for the imaging they used drone.
For imaging, okay. But as of when we are talking about robotics, when we need to worry about this mishappening, and we should be technically sound in order to recover the people who stuck with these mishappening. And please make a think over the issue. And I think one girl from your class already started doing work with the drone, and I request her to unmute. I think what. Go ahead and unmute your mic and please share the views. I am. I don't know her name. One from your class started working with the drones. I think Shivani. We have Shivani in our class. Yes, Shivani. Go, Shivani. Not yet joined,
Yes, sir. I believe she has not yet joined.
Okay. We'll spend some more time with our PPD. Okay. And see the list configuration. It is mandatory to handle with the object. We need to worry about. We need to concise about the information related to the list configuration, as we taught earlier. Yes. Yes. Someone. Yes.
Yes, sir. This is Shivani, sir.
Yes, Shivani. Where you went, Shivani?
I had a network issue, sir, so I had to rejoin.
Oh, okay. If it is so, what was your project, Shivani? You please share some content related to your project.
Sir, our project is actually inspection drive copter, sir. So what it does is it's actually a convertible drone. It can be a drone and it.
Just a minute. Before that, who are all your project members?
Sir, Ashwin from Triple E and then Lokesh and Satish from EC.
You three alone doing?
Yes, sir. We four of us are doing, sir.
Four. Who is the fourth one?
Lokesh and Satish, sir. Lokesh is one person and Satish is the other one.
None of them from production.
No, sir. Nobody's from production.
Okay. Yes. Go ahead. Yes, tell me.
Yes, sir. So it is a convertible drone. So it can fly as a drone and also as a four-wheel robot. So we had come up with a mechanism to convert like a self-transforming mechanism so that it can convert from a drone to a four-wheel drive copter. And that's it about it, sir. So we also have a camera to inspect through narrow spaces. So what it exactly does is, depending on the space that is available, it will contract itself.
Good. Very good. Appreciation from our side. Go ahead. And if it is feasible, you make it as a very tiny. Because a
Yes, sir.
student from Shasta who is already developed a satellite for NASA. He developed a satellite which weight is very negligible.
Yes, sir. It was around 30 grams, I think.
Yes. Have you heard about his name?
No, sir. I don't know his name, sir, but I know about the projects.
Yes. Yes,
Yes.
if it is feasible, we'll make uh, a conversation with him. I'll arrange one conversation with him. What all the things he made, I'll try to catch him, and if it is feasible, during our class itself, I'll ask him to deliver some content.
Yes, sir.
Anyway, our appreciation from the entire class. You go ahead. It is a very good work. And in the tomorrow or in the Friday class, we have Friday 9:30. We have class.
Yes, sir.
Yes, sir. 9:30.
Yes, we'll discuss about the wrist configuration, and slowly we'll enter into the programming and all. Yes. Do you want to share anything? I think
No, sir.
Shivani, do you have anything to share? Or
No, sir.
someone started to communicate something. Yes, if it is no, then we'll wind up the session. Friday 9:30 we'll meet.
Okay, sir.
Thank you, Anand.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.